Right, so this is the third video in the series on radicals and fractional exponents. We're still dealing with radicals, square roots, and cube roots. We want to look at multiplying here. Two radicals. Let's say the square root of 6 times the square root of 14. So what I want to do, so they're both square roots, so we take the common radical, which is the square root, and then multiply underneath. 6 times 14. Okay, so we have the square root of, what's 6 times 14? 6 times 14 is 84. Oh, let's make it right. Now, is 84 a perfect square? No, it's not, right? 84 is somewhere between 81 and 100. It's not a perfect square. And the question is, can we factor 84 into anything where one of those numbers is the perfect square? The largest perfect square you can think of. Think about that for a second. Yes, right? 4 times 21, right? We can do 4 times 21. 21 is having 2 primes in it, right? 3 and 7. And 4 is a perfect square. Now 4, because it's a perfect square, it gets out of jail. The square root of 4 is 2. So 4 comes out of jail, it becomes 2. And under the radical stays 21. 21 has no perfect squares inside of it, right? Just 3 and 7 make up 21. So there we have it. 2 times the square root of 21. Number 2. How about, let's do some cube roots. We haven't done any of those, have we? How about the cube root of 9 times the cube root of 6? Cube root of 9 times the cube root of 6. So let's think about writing here 9 times 6 under our common radical, the cube root. What is that equal to? That's equal to the cube root of 9 times 6 is 54. So are there any perfect cubes that 54 is factorable by? Let's think about our perfect cubes. So 54 is definitely not a perfect cube, right? 54 would be somewhere in between 27 and 64. It's not a perfect cube. But are there any perfect cubes that 54 is factorable by? Yeah, 27, right? 27. 27 right here. 54 is 27 times 2. So the cube root of, we're going to write this as 27 times 2. That's just another name for 54. Now, 27 gets out of jail because he's a perfect cube. What does he become? He becomes a 3, right? The cube root of 27 is 3, so we take him out of the jail. 27 comes out of the jail, becomes a 3 because the cube root of 27 is 3. And under the cube root symbol, we're going to leave a 2, a red 2. 2 is not a perfect cube, so he does not get out of jail. So 3 cube root of 2, or 3 times cube root of 2, is our answer. All right, let's see. Can we do another? How about number 3? How about the cube root of 7 times 98? Cube root of 7 times the cube root of 98, rather, I should say. All right, so we're going to make, since we have a common cube root here, we're going to make a single cube root, and we're going to multiply 7 together with 98 under the radical symbol. So I guess the question is, what is 7 times 98? Well, I don't even know that, so let me get out a calculator. 686. Now, are there any perfect cubes within 686? 686, first of all, is not a perfect cube. So I'm looking along here. 686 would be somewhere like between 512 and 729. But are there any perfect cubes that 686 is factorable by? So we can try, I don't know, is 686 divisible by 8? No. Is 686 divisible by 27? No. Is 686 divisible by 64? No. Is 686 divisible by 125? No. Is 686 divisible by 216? No. Is 686 divisible by 343? Yeah. 343. That guy right there. So 343 is a factor of 686. So let's write it this way. Cube root of 343 times 2. That's the way 686 breaks down. Now, we know that 343 is a perfect cube, right? It was in our list. What is the cube root of 343? Well, it's going to be 7, right? 7 cubed gave us 343. So 343 gets out of jail and becomes a 7 because the cube root of 343 is 7. So we have 7, cube root of 3. No, it's cube root of 2. 7 cube root of 2. That's our answer there. Right? Cube root of 343 is 7. And leave the cube root, and the 2 stays under. 2 is not a perfect cube. All right. So how about number 4? About the cube root of negative 50 times the cube root of 15. The cube root of negative 50 times the cube root of 50. All right, so we have a common radical cube root, so we're going to make that cube root symbol. We're going to multiply negative 50 by 15. Put parentheses. All right, so what is that exactly? All right, the cube root. What is negative 50 times 15? Negative 50 times 15. Minus 750, right? Minus 750. Now, the question is, negative 750, is that a perfect cube? Definitely not, right? So we look at the positive perfect cubes here. These are all the positive perfect cubes. It would fall somewhere here between 729 and 1000. Positive 750 would. So it's not a perfect cube. Are there any factors? Are there any factors of negative 750 that are perfect cubes? So you could take negative 750 and try to divide it by 8, try to divide it by 27, try to divide it by 64, try to divide it by 125. You're actually going to find that 750 is divisible by 125. Turns out to be negative 6. Negative 6 times negative 125. I'm sorry, negative 125 times 6. So negative 125 times 6. Right, negative 125 times 6 will give you negative 750. Now, negative 125 is a perfect cube. It's a negative perfect cube. What happens when you take the cube root of negative 125? You get negative 5. So negative 125 comes out of jail. His cube root is negative 5, so he comes out as negative 5. And the cube root stays with the 6. Stays with the 6 because, yeah, 6 doesn't have any perfect cubes within it.